Hello, my dear students. Welcome to my channel, RK Study Circle IIT. I'm back with one more long answer question from functions chapter. Here was the second question. Let F mapping from A to B and G is mapping from B to C be bijections. Then show that G of F whole inverse equals to F inverse of G inverse. So in order to solve this question, first of all, we have to define the functions f and g are bijectives. So starting the answer with defining functions, not questions. So function f mapping from A to B is bijection, is bijection. In order to say a function is said to be a bijection, we have to write it in two ways. That is, the function must be 1 1 as well as onto. So in order to prove it 1 1, let me write first of all, let small a belongs to capital A, small b belongs to capital B, such that f of a equals to b, f of a equals to b. And from here, I'm actually writing f of a1 equals to f of a2 if and only if a1 equals to a2. If and only if a1 equals to a2. Therefore, I'm writing f is 1 1 function. F is 1 1 function. So when I'm writing f of a equals to b, then I have to say the function f is onto. The function f is onto. So from the same equation, can I mention a equals to f inverse of b? Yes, sir, obviously you can. Let it be equation number 1. Let it be equation number 1. So let me define the second function, that is g is the function that mapping from b to c. It a is a bijection. The function itself g is mapping from b to c is a bijection. Then we are supposed to write let small b belongs to capital B, small c belongs to capital C, such that g of input, that is b, equals to output c, right? So in order to write g is said to be the 1 1 function, I need to mention g of b1 equals to g of b2 if and only if b1 equals to b2, if and only if b1 equals to b2. Therefore I need to mention g is 1 1 function. G is 1 1 function. And the next one, G is said to be onto if and only if G of B equals to C. What I supposed to write this one? G is onto function. So as well as, can I mention B is equals to G inverse of C? Yes, sir, obviously. Let it be equation number 2. Let me mention this one is equation number 2, right? So we have defined what is function f is bijection and what is function g is also a bijection. In order to say a bijection function, the function must be both 1 1 as well as onto. So getting into the actual question that we are supposed to write this one, let me mention g of f mapping from a to c, a to c. So here let small a belongs to capital A, small b belongs to capital B, and small c belongs to capital C, such that g of f of input value was A and output value was equals to C. Therefore, here we have this equation g of f of A equal to C, right? So let me write A will be equals to how much? G of f of whole inverse of C. Let it be equation number 3. Let it be equation number 3. So what can I write from here? From equation number 1. From equation number 1 and equation number 3. What I supposed to write? A is nothing but what? F inverse of B. Kada? A is nothing but F inverse of B. So I'm writing the same. A is equals to F inverse of B and which is equals to G of F whole inverse of C. This is why I'm going to write B equals to, no, A equals to F inverse of B. A value was equals to F inverse of B from equation number 1, right? And what do you have to write? B is nothing but what? B is nothing but what? We have B is nothing but G inverse of C, where I have written G is the function that is onto in nature. Therefore, I am mentioning F inverse of G inverse of C. F inverse of G inverse of C, that equals to G of F whole inverse of C. No, no. G of F whole inverse of C. So rewriting this equation, F inverse of G inverse will multiplied with C, that equals to G of F whole inverse of C, right? From here, you can cancel out C and C on both right hand side and left hand side. Therefore, you left with F inverse of G inverse, which is equals to G of F whole inverse, G of F whole inverse. So rewriting this equation, you can write G of F whole inverse will be equals to F inverse of G inverse, F inverse of G inverse. What can you write here? Left hand side is equals to right hand side. Am I correct? This is what they have given in question, and we are supposed to prove this equation. That is the reason why we are writing LHS equal to RHS. Hence, you can say the function g of f map g of f whole inverse equals to f inverse of g inverse. Therefore, you can say hence hence proved. Hence proved. That's it. It's a very simple question. You can write it in matter of minutes, something 3 to 5 minutes only, not more than that. So just look at the components what I have written here. So this is the same thing what we have dealt in question number 1 also. Function f and g are bijectives. When they are bijective, I'm actually defining what does bijective means. So the function must be 1 1 and onto. So from here to here, I have defined function f is bijection. That is both 1 1 and onto, right? Uske baad, the function g is said to be bijection. Means it must be both 1 1 as well as onto, right? That is also I have defined. So this is the same steps what we are following in question number 1 also. The same thing you need to proceed in next upcoming questions too, right? So after completing this, I'm simply writing g of f, the composite function mapping from A to C. That is also a bijective function that we already know. And I'm actually writing its formula. I'm actually writing its formula, that is g of f whole inverse of A equals to C. So where you can write A is nothing but g of f whole inverse of C. From here, equation number 1, 2, and 3, you can manipulate on your own. You can manipulate the equations and you can get this expression where g of f whole inverse equals to f inverse of g inverse LHS equal to RHS, hence proved. So that's it. The question is very easy from the long answer questions are very easy from functions chapter. So you're not supposed to skip if any question is falling from functions. Okay.